So, dear students, welcome to the lecture of control systems. In this lecture, we will discuss about the introduction to the control systems, what actually a control system is. So, this lecture will cover the introduction part of the control systems and types of control systems, and we will see some examples also. What is a control system? A control system is basically a way of obtaining a desired output from a given system in controlled way, right? So when we have a system which has further subsystems and processes, so if they are arranged in a particular manner, a proper manner, so that we can get a desired response, desired output for a given input, we call it as a control system. We can also say that a control system is a methodology that is applied over a given plant, process, subsystem, sub-processes, so that we can get a desired response from that plant, from that subsystem or system or processes, right? So as you can see here, this is a kind of block representation. Okay, so we have the input to the control system. We can call it as stimulus, right? We can call it as input. We can call it as the reference. So reference is actually the value that we desired to get out of the system as its output, right? And the output or response of the system is the output or response or the actual response, right? Okay, so this actual response may be desired response, may not be desired response. There may be some error also, right? However, uh, ideally we want that a control system shall give us the desired response, right? For example, if I have uh, uh, a control system which is to control the temperature of a room, and if the desired value is 25 degrees centigrade, then this control system shall maintain the temperature of room to 25 degrees centigrade only. However, practically it may be above 25, little bit above 25, little bit down 25 degrees centigrade, right? Because of various practical reasons. Okay, this is basic. Okay, schematic. Fine. Now we have one more block diagram representation, as you can see. So here we have this example related to some vehicle, right? So we have two blocks shown here: the accelerator pedal, and then engine vehicle, and the input is given to the accelerator pedal, which is the force. So when you have to accelerate a vehicle, you apply force on the accelerator pedal, and the output is the speed. The vehicle gets, you know it gains speed and it runs fast, right? And there is something which is changed or manipulated, that is the rate of fuel flow. So when you accelerate a vehicle, the rate of fuel flow increases, and hence the speed of vehicle also increases, right? And when you deaccelerate the vehicle, you release the force from the accelerator pedal, and hence the rate of fuel flow decreases and speed also decreases, right? So yeah, that means that the system has an output for a specific input, specific command. Okay, so what are the various examples of control systems that are associated to our daily life? In this, we have an air conditioner. So it is one example of control systems. Okay, then refrigerator. Okay, then so air conditioner twice has come here. A bathroom toilet tank. Okay, so you can see in toilet tank, when you flush the water and the the tank gets empty and then it is filled, and there is a ball valve there. So when the water rises in the tank, the ball valve also rises up, and eventually it shuts the opening of the water inlet to the tank, and hence the water stops coming into the tank once it is filled with water, right? Then we have automatic iron. When you set the automatic iron on a specific uh, value of temperature for the specific fabric, so the when the temperature increases beyond that value, the iron automatically gets off. It is cut off from the supply, and when the temperature goes beyond below that value, again it is turned on. So in this way it is turned on and off. So we generally call it as on off control. This is an on off control example. So many cars which have cruise control system mechanism, so they are the example of control systems which we use in our daily life. So configuration of control systems. Control system can be configured as an open loop control system and also as a closed loop control system. So in an open loop control system, we have an input, we have a command, basically we have controller, we have plant, and then we have output. There is no way to monitor the output, and there is no way to measure the output and give it this as a feedback to the input, right? So it is totally an input and output kind of system with a controller and plant, right? We do not have any provision or mechanism to measure the response of the system, right? In this particular type of configuration of control system, the uh, response of the system is uh, you know uh, though depend upon the input, but the command signal which is generated by the controller is totally independent of the output of the system. That is, controller does not know the response, how the plant is responding, okay, because it is not monitoring the response of the plant. Fine. So the examples could be the electric hand dryer, then automatic washing machine, bread toaster, automatic tea, coffee maker, timer-based clothes and dryer, light switch, volume on stereo system. All these could be the best example of open loop control system, which are used in our daily life. Then we have another configuration, which is closed loop configuration of the control systems. In the closed loop configuration, the response of the system has uh, signifying effect on the input quantity in a manner by which the output or the response is adjusted, right? That means the controller can monitor the response of the system and changes the control variable in such a way that it can adjust the response of the system to the desired value. So this is the block diagram representation of a closed loop control system. In this, we can see we have a controller, we have plant, then also we have feedback elements. So these feedback elements, as you can see, they monitor the response of the system, measure the output of the system, okay, convert that output into an equivalent quantity and send that to the comparator. This is a comparator, or we can also call it as error detector. So here the feedback value is compared with the input, and a difference which we call as an error signal is identified or detected. This error signal is given to the controller. On the basis of this error signal, controller decides the control variable which it generates, and this control variable is sent to the plant so that some of the parameters or processes of the plant can be manipulated or adjusted so that the response of the system can be forced to remain within the desired bounds or limits, right? So uh, This error is nothing but the difference of input and this value which is fed back here. This error plays a very important role. Error signifies the deviation of the response of the system from the desired value. Now, there are certain differences between the open loop and closed loop systems. The fundamental difference between an open loop flow control systems and closed loop control systems is the feedback action. Open loop control systems do not have the feedback mechanism. That is, there is no provision to monitor and measure the output of the plant, right? And compare it with some input or reference signal. There is no provision as such. However, in closed loop control system, we have feedback mechanism. We have the provision to monitor, to measure the response of the plant and give that signal as a feedback value, compare it with some reference value, generate an error signal, and in this way we can keep on adjusting the output or response of the system. Now, what is feedback? Feedback is actually the process of measuring variables that need to be regulated so that corrective actions can be taken. Okay, so feedback is a provision or a mechanism which is provided in the closed loop control system. And so there are five basic elements of a feedback flow control system. Feedback control system is nothing but the closed loop control system. So it is nothing but the closed loop control systems, right? So we have an input element, we have process being controlled, means the plant, actually the output, the sensing elements, controller, and actuating devices. Actuating devices are actually the valves, actuators. Okay, these are the valves or actuators. For example, a switch, a relay, they are the best examples of the actuating devices, right? So then practical examples of closed loop control systems. So practical examples are here. Automatic electric iron is one practical example of automatic control system. Though it is a non-off control, but yes, it is a closed loop control system. Servo voltage stabilizer is another example. Water level controller is one example which we, the use of this is seen in our daily life. Missile launched and auto tracked by radar. This is a closed loop system. Then an air conditioner means an automatic air conditioner, right? Cooling system in car, right? So all these are the examples of closed loop control system. Now, there are certain advantages and disadvantages of open loop control system. Okay, so now when we see the advantages of open loop control systems, we can say that open loop control systems have simple design, simple construction, because they do not have extra elements like feedback elements. Open loop control systems only have the controller, they only have the plant, right? So additional elements are not there, and hence we can say their construction design are simple. And because they do not have extra additional elements connected into them, so they are economical. They are economical. They can be easily maintained. They are generally stable, and they can be conveniently used. Okay, so now disadvantages are like they are inaccurate sometimes, right? They are inaccurate because controller does not know the response of the plant, how the plant is responding. Okay, controller is totally blind to the response of the plant. Okay, because we are not monitoring the output of the plant, we are not monitoring, we are not measuring it also, right? And hence controller doesn't know that how the plant is responding. Controller will only assume that okay, the plant would be responding in the desired manner, but there may be a possibility that the plant is not responding in the desired manner. So this may lead to the inaccuracy, and hence the open loop control systems are inaccurate sometimes. They are unreliable. Okay, so because there is no monitoring, there is no measurement of the response, controller doesn't know anything about the plant's response, and hence So we cannot rely on their performances. Any change in the output cannot be corrected automatically. So because uh, we don't have any feedback mechanism here, so we cannot adjust the output of the plant automatically, right? So now similarly, closed loop control systems have some advantages and disadvantages. So the advantages are like, advantages are like closed loop control systems are more accurate because we have the feedback mechanism here. The controller actually knows how the plant is responding, and controller can take corrective actions in time to avoid any kind of inaccuracy or any kind of deviation of the response of the plant from the desired value, right? So highly accurate because the error is corrected by the feedback signal. And then bandwidth is it is large, facilitates automation. Okay, because closed loop control systems are automatic control systems, so they are advantages to the automation, right? The sensitivity of the system may be made small to make the system more stable, right? The system uh, can be less sensitive to the uncertainties, disturbances, noises, right? And hence is more stable as compared to the open loop system, right? Okay, and closed loop control systems are less affected by noise. So the disadvantages are like, because we have some additional components like feedback mechanism, feedback elements there, comparator is there, error detector is there. So we can say that closed loop control systems are not cost effective. They have complex design because of the presence of feedback path and comparator or error detector. Okay, and because of this, they need more maintenance, right? The feedback may lead to oscillatory response, damped response, right? Or under damped response. The overall gain is reduced to the due to the presence of feedback, and stability is major problem, and more care is needed to design a stable closed loop system. Because of the addition of additional components, there is a possibility and probability that the system may go unstable, right? So as compared to the open loop control systems, closed loop control systems are quite less stable. So the comparison is shown here, right, between open loop and closed loop control systems. So we have feedback element in control closed loop control systems. We don't have any feedback in the open loop, no error detector in open loop. Open loop are more stable as compared to closed loop, right? Simple construction, economical, small bandwidth. Closed loop have large bandwidth. Okay, so all these are the comparisons between open loop and closed loop control system. So here is one example of closed loop control system. This is a pictorial demonstration of the person steering an automobile as a feedback control system, closed loop control system. So because your feedback control system has controller, plant, feedback mechanism, error detector, these are the basic elements, right? So in this, we can say that the feedback elements or sensors actually are our eyes, hands, which are steering the wheel position, feet, which are on the accelerator and brake position, nose, problem, orders, ears, noise, talking, etc. Right? Okay, so nose, if there is any order, so it may create a problem or it is a kind of disturbance to the driver. Ears may are continuously listening to some noise and or talking on voice, different voices, so that is also kind of disturbance, right? So the controller is brain, right? And brain itself is an error detector, right? So processor, heading processor, actuators are hands and steering wheels, right? So we will be using hands while driving a car, and the objective is to keep the car in the direction and in controlled speed, right? So the output variables would be, when we drive a vehicle, the output variable or output parameters are the direction, okay, that need to be taken care of. And then the another output variable is the automobile speed, okay, that needs to be controlled, right? So both of them, that is the direction of the vehicle and speed of the vehicle, need to be taken care, right? So this is a closed loop control system, and this is how we can design this, and we can relate this with this block diagram, right? Similarly, we have batch chemical process, wherein let us say some chemicals or reactants are being mixed and some product is being formed, right? So we have a stirrer here. This is a stirrer, okay. So stirrer is actually used to mix the reactants so that the specified product can be, or desired product can be formed. We have temperature sensing element within the reactor. We have a cooling jacket outside it so that the temperature within the reactor can be controlled, right? So this is also a closed loop control system example, right? So all the components are connected here. So now this was it for today's lecture, guys. Thank you so much.